To calibrate the oxygen, we're going to remove the pH electrode from its slot because we need the temperature data from that electrode, and we need that temperature, that whole electrode and the oxygen probe to be in this at the same temperature. We take the pH electrode out of the head, put it in its little moisture cap, unscrew the fiber optic connector from the head that has the oxygen dot on it.
This is the calibration sleeve. Pull the cap off and add a little bit of water to the foam in the bottom. You just want that damp, so shake out any excess water. Put it back on, and now insert your oxygen probe into the calibration sleeve. This is to keep the probe humidified during the calibration procedure. Ideally, you would leave these two to equilibrate to the same temperature. If you have a nice stable lab temperature, wait for about an hour for the two to equilibrate. If you had a water bath at a certain temperature, you could put them both in and let them equilibrate in the same temperature water bath. We're going to do this just as our very stable lab temperature, and they've been sitting here together for about an hour. So the two temperatures of the oxygen probe and the pH electrode should be the same.
And we're standardizing the oxygen against 100% air.
Correct.
So here we go, back to our tablet.
In this case, we will go to Utilities, to Oxygen Calibration. Our calibration factors will show up for us. The temperature that we're going to be using is the temperature that our pH electrode is registering, currently at 22.50. What we're looking for is the phase number, this 100% phase number. We're in 100% saturation because we're in air, so we need to get that number. So what we are going to do is we're going to go back to our raw data stream. In our raw data stream, we're going to look at the current 100% phase number, which is 27.91. It may be jumping about a little bit in that last decimal place. We can wait for a little bit and take several numbers and average them, which we normally do. We normally take 10 of these measurements and make an average. For this, I'm just going to read this off as 27.9. Our temperature 22.56. So again, back to the O2 calibration. Our 100% phase. Do you remember it, Alina?
27.9.
Well, if we have a question, we can back out of this.
Go back to raw data stream.
Go back to raw data stream. 27.89.
Yeah, it was rounded up to 9.0. Yeah.
So 27.8 excuse me, back it up. 0.89, done. Our temperature is the same one we're reading up there. 22.62, done. And when I hit calibrate, this will write this back to our memory. In this case, the O2 calibration does not need to reboot the system. So we're back calibrated, we're in air, and you see our measurement now for our oxygen is showing 100%. We're in air, 100% saturation. The other factor on that table is the 0% phase. Excuse me. Again, it has a phase number and a temperature number. Ideally, we would want the temperatures that we calibrate at to be within 3 degrees Celsius of our use temperature to minimize error. The 0% phase, as it turns out, does not have a big change as the 100% phase. We do this by purging our oxygen electrode with pure nitrogen so that we have no oxygen in the system, and read the 0% oxygen number to get that phase number, and again at the temperature that we're doing that has to be done. Our experience has shown that These dots are very stable for this 0% phase number, and we usually do not have to recalibrate the 0% phase once it has been calibrated. In the field, to fine tune our calibration, we use this air saturation 100% that we just went through to finalize our calibration. That's it.